The warehouse in Kammerdorf was very quiet on the morning of January 12, 1943. Outside, snow covered the proving grounds where the German army had tested tanks and big guns for 20 years. Inside, under harsh electric lights, three engineers from Hereswa, the Army Weapons Agency, stood around a small boxy vehicle painted an olive drab green. It had been captured 6 weeks earlier in North Africa, pulled from a wadi near Sidi Bouzid after its crew left it during a quick retreat. The recovery team had towed it back behind German lines. Curious about its strange look, it was smaller than a Kubelwagen, simpler than anything they had ever seen, and yet American forces seemed to have thousands of them. Now it sat in Germany's top military research facility, ready to be taken apart and studied. Hauptmann Ernst Schneider, a mechanical engineer who had designed parts for the Panzer Mark V, walked slowly around the vehicle. His boots made echoes on the concrete floor. He held a clipboard and wore the gray-green uniform of the Wehrmacht Technical Services. Next to him were two civilian engineers from Daimler-Benz, men who had spent their whole careers making cars excellent, who knew that a proper military vehicle needed precision, strong engineering, and many backups for safety. They had come expecting to prove what everyone in the Reich already believed, that American equipment was rough, mass-produced trash, made by a nation that cared more about numbers than quality, building everything fast and cheap. Because Americans themselves were soft, undisciplined, and could not match the strict engineering skill that German industry had. Schneider put his hand on the vehicle's hood. The metal was thin, stamped steel, maybe 1/16 of an inch thick. A good strike from a rifle could dent it easily. He opened the hood and looked at the engine. It was a 4-cylinder inline motor, flathead style, 134 cubic inches, in a rough cast-iron block with a simple valve system. Everything about it looked farm-like it should be on a tractor, not a military vehicle. One of the Daimler engineers, named Friedrich Waber, actually laughed. "This is what they bring to fight the Wehrmacht? Just look at this engine. We made better engines in 1930. But Schneider did not laugh. He was counting the parts, counting the fasteners, counting the number of different bolt sizes. His face got more serious with each count. He moved to the transmission, a simple 3-speed manual with a 2-speed transfer case. He checked the suspension, leaf springs in front and back, the most basic design you could imagine. He looked at the wheels, stamped steel, not even real spoke wheels. Everything about this vehicle broke every rule of German engineering. And yet Schneider pulled out a specification sheet that intelligence had made from interrogations and captured documents. This vehicle, the Americans called it a Jeep, a name that came from the military letters GP for general purpose, had been made in huge numbers. The sheet said over 100,000 had already been built and production was going faster. Ford and Willys Overland, two companies, were making them in many factories. He looked back at the Jeep. A question came into his mind, one that would trouble German military leaders for the rest of the war. How could something this simple, this crude, this totally wrong, by every proper engineering rule, be winning? To understand what these engineers saw when they looked at that Jeep, you have to know the philosophy that guided German military manufacturing in 1943. It was a philosophy born from tradition, from pride, from a belief that more complex meant better. German engineering had been the best in Europe for decades before the war. Mercedes-Benz made the world's best cars. Zeiss made optical instruments with perfect precision. Krupp made artillery that set world standards. This was not propaganda. This was real, measurable fact. A German camera lens really was sharper. A German machine tool really held tighter measurements. German craftsmen trained for years as apprentices before they were allowed to be called skilled workers. This excellence created a national identity. Germany saw itself as the land of poets and thinkers, but also of engineers and scientists. The periodic table was partly organized by German chemists. The diesel engine was German. Rocket science, jet engines, and synthetic materials. Germany led in all these fields. This was not empty bragging. These were facts. When applied to military equipment, this thinking made vehicles like the Kubelwagen, Germany's version of the Jeep. The Kubelwagen was designed by Ferdinand Porsche, a man who would become famous in car history. It had a rear-mounted air-cooled engine, independent suspension on. All four wheels in a body shaped by aircraft designers to be light but very strong. It was clever. It was sophisticated. It was German. If you are enjoying this deep dive into the story, hit the subscribe button and tell us in the comments where in the world you are watching from today. But the Kubelwagen needed skilled workers to build it. Its air-cooled engine required precise machining. Its independent suspension used complicated swing axles and reduction gears. Each vehicle needed hundreds of man-hours to put together. Quality control was very strict. Parts were inspected, measured, and tested. Nothing left the factory unless it met exact standards. This method applied to everything Germany built. The Tiger tank had an 88mm gun with incredible accuracy and power, but each Tiger took 300,000 man-hours to make. Its engine was a 23-liter V12 masterpiece with 700 horsepower, but it needed skilled mechanics to maintain it and used fuel very fast. The Tiger was almost unbeatable in battle. Germany made fewer than 1,400 of them in the whole war. The German military thought this was the right way. Wars were won by better soldiers using better equipment. One Tiger could destroy 5 American Sherman tanks. One Messerschmitt Bf 109 could shoot down many Allied fighters. One German division, properly equipped and trained, could beat 2 or 3 Allied divisions. Quality would beat quantity. This belief was made stronger by early successes. In 1940, Germany had conquered France in just 6 weeks. In 1941, German armored forces had driven 500 miles into the Soviet Union in the first month of the war. The Blitzkrieg worked. Speed, violence, and better equipment had overwhelmed enemies who had more soldiers. The Wehrmacht had proven the idea. Why would they change? By 1943, when that jeep arrived at Kammerdorf, Germany controlled land from the Atlantic coast to the Volga River and from Norway to North Africa. The Reich had conquered 2 continents. It had done so with armies that, soldier for soldier and machine for machine, were better than anything their enemies had. The German soldier was better trained, better led, and better equipped. This was simply true. So when Hauptmann Schneider and his colleagues looked at this crude American vehicle, they did so with complete confidence that German engineering was right, proven by victory after victory. The Jeep, with its simple engine and stamped steel body, was exactly what they expected from America. Quantity without quality, production without pride, vehicles made by a nation that didn't understand war. Schneider started his examination step by step, the way German engineers approached everything. With careful precision, he made a form with categories: engine, transmission, suspension, electrical system, body, and overall assessment. Each category would get detailed measurements, part counts, and quality ratings. The engine came first. 4 men lifted it from the chassis. It weighed only about 400 pounds and was placed on a workbench. Schneider took it apart completely, laying each part in neat rows, connecting rods, pistons, crankshaft, camshaft, and valves. He measured everything with German calipers and micrometers, tools accurate to a thousandth of an inch. What he found was surprising, not because it was fancy, but because it was so deliberately simple. The engine block was a single iron casting with no separate cylinder sleeves. The crankshaft ran in just 3 main bearings, not the 5 or 7 found in German engines. The camshaft sat directly in the block without separate bearing inserts. Everything was made to be cast, not machined. Weber, the Daimler engineer, pointed out each weakness. Look at this crankshaft. No counterweights. The vibration must be terrible. And these pistons, cast aluminum, not forged. They will fail under high RMRP. But Schneider was looking at something else. He was counting fasteners. The whole engine used only 7 different bolt sizes. 7. A similar German engine used over 30 different types. He looked at the oil filter, a simple cartridge that could be changed in seconds. German engines use complex filters that needed partial disassembly to fix. If you are enjoying this deep dive into the story, hit the subscribe button and tell us in the comments where in the world you are watching from today. The carburetor was amazing. It was a single-barrel unit, simple but easy to use. Schneider could see how it worked just by looking. No hidden passages, no complicated linkages. He timed himself taking it apart. 4 minutes. Putting it back together, 6 minutes. A similar German carburetor needed special tools and training. He had seen mechanics spend an hour adjusting them correctly. The electrical system was also simple. The generator made just 30 amps. The battery was a normal 6-volt unit, but everything was mounted outside, easy to reach. Every wire was color-coded, and a simple diagram was stamped on a metal plate attached to the firewall. A diagram like the designers thought the mechanics would not know what they were doing, needing pictures to see what connected where. It was almost insulting. German vehicles came with detailed manuals, yes, but they assumed the mechanic had proper training. They assumed expertise. This Jeep assumed nothing. It was built for idiots. Schneider moved to the transmission and transfer case. Again, brutal simplicity. The gears were cut, not ground, leaving visible tool marks. German gears were ground smooth after cutting and often polished for final precision. These gears looked farm-like, but they were also big and overbuilt, with thick teeth that could handle huge shock loads. The transfer case gave a 2-speed reduction, giving the Jeep amazing low-range torque. But the mechanism was so simple, just a sliding collar and 2 gear sets, that Schneider could see exactly how it worked. No complex planetary gears, no tricky dog clutches. Even a farm boy could understand it by looking. By the end of the first day, Schneider had filled 20 pages with notes and measurements. The other engineers got bored and left. This was beneath them, looking at American trash. They had real work to do, real engineering projects that mattered. But Schneider stayed because, with each measurement, each part counted, each system studied, a troubling picture was forming. This vehicle wasn't crude because American engineers were bad. It was crude because they made it that way on purpose, intentionally. Every simplification was planned. Every reduction in complexity was calculated. And if that was true, it meant the Americans understood something about war that Germany had missed. Something basic, something that might explain why, even with German engineering being better and victories across 2 continents, the war was starting to turn against them. Schneider spent the second day focused entirely on production. This was the part that worried him most. He got intelligence files on American car manufacturing from before the war, reports from German businessmen who had visited Detroit, and recent studies of serial numbers on captured equipment. The Jeep in front of him had a serial number showing it was made by Willys Overland in Toledo, Ohio, in November 1942. But intelligence showed that Ford was also making the same vehicle in factories in Michigan and New Jersey. 2 companies, multiple factories, making the exact same vehicle to interchangeable standards. Schneider understood what this meant. The Americans had standardized everything. Every bolt, every bracket, every wire clip was exactly the same, no matter which factory made it. A Willys Jeep would fit perfectly on a Ford Jeep. This was mass production on a scale Germany had never tried. He pulled production numbers from the intelligence files. In 1941, Willys and Ford together made 48,000 Jeeps. In 1942, that number jumped to 159,000. Estimates for 1943 predicted over 250,000. These were not numbers from Allied propaganda. These were German intelligence calculations based on shipping records, factory sizes, and serial number studies. Schneider did the math. Assuming 300 working days a year, American factories were making over 800 Jeeps per day. Per day. He looked at the vehicle in front of him. Complex enough to work well, simple enough to build in hours instead of days. If you find this story interesting, please subscribe and turn on notifications. It helps us keep making deep stories like this. He compared this to German production. The Kubelwagen, by contrast, was made at about 14,000 per year in all factories. The Americans were making 18 times more light vehicles. 18 times, and this was only one type of vehicle. Intelligence reports showed similar ratios for trucks, tanks, planes, and ships. But Schneider looked even closer. He checked the Jeep's parts one by one, thinking about how easy they were to make. The body was stamped steel, made from simple molds that semi-skilled workers could use. Making these panels needed big presses, yes, but once the molds were ready, production was fast. A German version would have been hand-shaped or needed many complex stampings welded together. The frame had 2 parallel channel sections, cross-braced, simple to cut, simple to drill, simple to weld. No complex curves, no compound angles. A basic welder could put this together in an hour. The German version had tubular construction with carefully calculated stress points, needing skilled workers to get everything aligned properly. The suspension mounting points were simple but very strong. The spring shackles were heavy steel, overbuilt for strength. They looked farm-like because they were made like farm equipment that could survive abuse by untrained users. German suspensions were more advanced, yes, but they needed adjustment and maintenance. These leaf springs needed nothing. They either worked or they broke, and breaking them took extreme abuse. Schneider looked at the wheels and tires. The wheels were stamped steel, 3 pieces welded together. Simple but able to be made on huge presses very fast. The tires were bias ply, size 7.00 by 16, nothing special, but intelligence showed that Americans had used this size on many vehicles. The same tire that fit the Jeep also fit some trucks. This meant easier logistics and interchangeable spare parts. He went back to the engine, this time looking at it from a production view. The cylinder block was a single iron casting. One piece poured in a mold, cooled, and then machined. The machining needed only basic operations, boring the cylinders, facing the deck, cutting the valve seats. Any machine shop could do this. The cylinder head was another simple casting. The manifolds were cast iron, not made from steel plates. Every part was designed for mass production. Nothing needed hand fitting. Nothing needed skilled workers to adjust. The whole vehicle could be put together by workers with minimal training using simple tools. The Americans even made special wrenches, combination tools that fit many fastener sizes, so fewer tools were needed. Weber had dismissed this, saying it was proof of American stupidity. They designed for their workers' stupidity, he said. But Schneider was starting to see it differently. The Americans were not designing for stupidity. They were designing for scale. They were designing for a totally different kind of war than Germany was fighting. He pulled out his notes from a lecture he had attended in 1941, given by a Wehr logistics officer. The officer had calculated that Germany could support about 3 million men in the field with the factories they had. This assumed normal losses, regular equipment replacement, and full output from German factories, plus those in occupied territories. The Americans, according to that same officer, could maybe field similar numbers, but their equipment would be worse. Their supply lines would be stretched across the Atlantic, and their soldiers would not have German training or discipline. Quality would beat quantity. Schneider looked at the Jeep. What if those assumptions were wrong? What if the Americans could make equipment faster than Germany could destroy it? What if simplicity was actually a smart strategy? On the 5th day of studying the Jeep, Schneider wrote a formal report. Normally, he would send it through the Heereswaffen Technical Directorate, where it would be reviewed, summarized, and filed. But something in his conclusions worried him so much that he asked for a meeting with General Major Wilhelm von Thoma, who had just returned from North Africa and was advising on armored vehicles. Von Thoma agreed to come to Kammerdorf on January 19, 1943. He arrived in the afternoon, a tall man with a scarred face and the Knight's Cross on his chest. He had led Panzer units in Poland, France, and Russia before going to Africa. He had been captured by the British at L'Alamein and was recently returned in a prisoner exchange because of his injuries. Schneider showed the Jeep and his findings in a conference room next to the workshop. Von Thoma listened quietly, smoking cigarettes and studying the photos and specifications Schneider had prepared. When Schneider finished, von Thoma was quiet for a long moment. Then he spoke, and it was not what Schneider expected. "I have ridden in these vehicles," von Thoma said quietly. "The British captured hundreds in North Africa. They loved them. Their officers used them all the time. I was taken to the prison camp in one. In 2 years of fighting, I never saw one broken down by the side of the road. Not one. If you find this story interesting, please subscribe and turn on notifications. It helps us keep making detailed content like this." Von Thoma stood and walked to the Jeep, putting his hand on the same hood Schneider had touched days earlier. "Do you know what I saw in Africa?" he asked. "I saw a British supply column stretching to the horizon. Trucks, thousands of trucks, all running, all moving. American trucks, most of them. I saw airfields where the British had more fuel in drums than we had in all of Rommel's army, von Thoma said, turning back to Schneider. We kept destroying their equipment. We would overrun a position and find it abandoned, full of supplies, ammunition, food, water, fuel, medical supplies, all left behind because they had so much. More coming. We thought we were winning because we were destroying their equipment, but we were not winning. We were drowning. He picked up Schneider's report and flipped through the pages. Your analysis is correct. This vehicle is crude. But I will tell you what it is not. It is not unreliable. It is not hard to repair. It is not rare. In North Africa, the Americans and British had these vehicles in such huge numbers that they used them for everything. Reconnaissance, supply transport, ambulances, gun tractors, command vehicles, even fighting vehicles with machine guns mounted on them. We had the Kubelwagen, which is better in every technical way. But we had thousands. They had tens of thousands. When one of theirs broke, they pushed it aside and took another. When one of ours broke, we spent hours fixing it because we had no replacement. Schneider felt a change in his understanding. Herr General, are you saying that their way is better? I am saying their way is different, and we have not adapted to it, von Thoma said, sitting down heavily, suddenly looking very tired. German manufacturing is made for a European war. Short, decisive campaigns, quality equipment kept by skilled mechanics. We win the first battles with better training and machines. Then we consolidate, refit, and get ready for the next campaign. He gestured at the Jeep. The Americans are not planning a European war. They are planning an industrial war, a war of attrition, where victory goes not to the most skilled, but to the side that can take losses and keep fighting. They are building equipment that any fool can use and any half-trained mechanic can fix. They are building it in such huge numbers that losing some doesn't matter, Schneider realized. We cannot match their production, von Thoma said, shaking his head. We are already at full capacity. Every factory in Germany and occupied Europe is working all the time. We are forcing workers from conquered lands. We are using prisoners of war. We are taking parts from captured equipment, and still we cannot make enough. He stood to leave, then stopped at the door. Finish your report, Hedman. Make it complete. Send copies to every office that matters. Maybe someone will listen, but I doubt it. Germany has convinced itself that quality beats quantity. We have shown it in battle after battle. Why would we change? But you think we should change? Von Thoma looked at the Jeep one last time. I think we need to understand what we are facing. The Americans are not sending their best equipment to fight us. They are sending the equipment that can be made the fastest. There is a difference, and if we do not understand that difference, we will lose this war. After von Thoma's visit, Schneider expanded his investigation. He requested every intelligence file on American industrial capacity. What he found was more worrying than the Jeep itself. The Jeep was just a sign of a bigger strategic reality that Germany had failed to see. The files had pre-war reports on American manufacturing, made by German military officers and business representatives who had visited the United States in the 1930s. These reports were detailed, correct, and worrying. They showed factories on a scale that didn't exist in Europe. Ford's River Rouge plant in Michigan covered more than 2 square miles of factory floors. It had its own steel mill, glass plant, and power station. At full production, it employed 100,000 workers making cars. One factory, 100,000 workers. Willow Run, a new bomber plant built by Ford outside Detroit, was included in 1942 intelligence updates. The building was 3,200 feet long, over half a mile, and a quarter-mile wide. It was the largest room under one roof in the world. Intelligence estimated it could make one B-24 Liberator bomber every 63 minutes once it was fully working. Schneider checked these reports against German production numbers. The entire German aircraft industry, combining Messerschmitt, Fokker, Wolf, Henschel, Junkers, and every other manufacturer, had made about 15,000 aircraft in 1942. American estimates said they would make 47,000 in 1943. The difference wasn't just in airplanes. Shipbuilding numbers were even bigger. American shipyards were building Liberty ships, 10,000-ton cargo vessels, in an average of 42 days from start to launch. Some yards had cut this to under 30 days. Germany's entire merchant fleet, built over decades, was about 4 million tons. America was adding over 8 million tons every year. But the scariest numbers came from tanks. The Jeep study led Schneider to look at American tank production, especially the M4 Sherman. Intelligence said multiple factories were making Shermans: Chrysler's Detroit Arsenal, Fisher Body in Grand Blanc, Ford in Dearborn, Pacific Car and Foundry in Washington State, and others. The Sherman was like the Jeep in how it was made. It was not the best tank America could design, but it was the best tank they could make in huge numbers. Its armor was enough, but not amazing. Its 75-millimeter gun was good, but not better than German weapons. Its reliability was good, but not outstanding by German standards. Yet America was building them in massive numbers. Intelligence said over 20,000 would be made between 1942 and 1944. Germany's entire Panzer force, all types and models from the start of the war through 1943, totaled about 38,000 vehicles. The Americans were almost matching that number with just one tank model in only 2 years. Schneider made another analysis comparing production methods. He called it Strategic Implications of American Mass Production Methods. The main point was simple. Germany and America were fighting different wars with different assumptions. Germany believed wars were won by better soldiers using better equipment in decisive battles. This had proven true in Poland, France, and the early Soviet campaigns. Germany had built its military around high-quality training, advanced equipment, and skilled support personnel. If you find this story interesting, please take a moment to subscribe and turn on notifications. It helps us keep making detailed content like this. America assumed wars were won by having more material and keeping it coming over time. They built their military around numbers, simple training, equipment that could be made quickly, interchangeable parts, and personnel who could learn fast. Every American vehicle was made so any soldier with basic training could drive it. Any mechanic with simple tools could fix it. Any factory with basic machines could build it. The effects were huge. German forces had to protect their equipment because replacements were rare. This made German units careful and conservative. American forces could be bold because they could replace what they lost. If an attack failed, they could refit and attack again and again. German supply chains needed skilled mechanics, special tools, and exact replacement parts. American supply chains needed only workers and basic wrenches. A German Panzer division that lost half its tanks needed weeks to get new ones, hoping they arrived before the division went into combat again. An American armored division that lost half its tanks could be back at full strength in days, using replacement pools that seemed endless. Schneider wrote down specific examples from North Africa. After the Battle of Kasserine Pass in February 1943, where German forces had beaten inexperienced American units, intelligence tracked the American recovery. Within 3 weeks, the Americans had fully replaced their losses. New tanks, new trucks, new jeeps delivered by ship to North African ports, then moved inland. The units that had been destroyed at Kasserine were ready for combat again before German forces could take advantage of their victory. The Wehrmacht, by contrast, had never fully replaced the losses it suffered during the 1941 Russian campaign. Divisions that started Operation Barbarossa with over 200 tanks were still running with only 70 or 80 tanks 2 years later. The replacements simply didn't exist. Schneider finished his report on February 3, 1943. It was 87 pages long, including photos, technical drawings, production analyses, and strategic assessments. He sent copies to the Heereswaffen Technical Directorate, the Vehicle and War Production Office, and directly to General Major von Thoma's office. The response was fast and completely predictable. Within a week, Schneider got a memo from his boss at the Heereswaffenamt. The tone was formal but clearly dismissive. The memo said his technical analysis was thorough, but questioned his strategic conclusions. It stated that while American production capacity was noted, German intelligence had always known about American industry. The memo said wars are won by soldiers, not factories, and that German tactical superiority had proven decisive against larger forces many times. It ended by telling Schneider to focus on more important tasks, like studying captured Soviet equipment and checking weaknesses in the new Panzer 34 tank. The Jeep analysis was filed and forgotten. But Schneider's report did reach one person who took it seriously: Albert Speer, the Reich Minister for Armaments and War Production. Speer had been appointed in February 1942, after Fritz Taut's death. Unlike many Nazi leaders, Speer was a practical man who understood industrial realities. He had already started restructuring German war production, trying to rationalize manufacturing and increase output. Speer's office contacted Schneider in March 1943 and asked for a meeting in Berlin. Schneider went to the Reich Ministry expecting a short consultation. Instead, he spent 3 hours presenting his findings to Speer and a small group of industrial planners. Speer listened closely, taking notes and asking detailed questions about American production methods. When Schneider finished, Speer was quiet for a moment, then spoke directly. "Everything you have documented confirms what I have been arguing for a year. Germany cannot win a war of attrition against the combined industrial power of America, Britain, and the Soviet Union. Our only hope is to make production as efficient as possible, simplified designs, and hope that our tactical skill buys enough time for political solutions." He pointed at Schneider's report. "I will use this. I will show it to the Führer, to Goering, to anyone who will listen. But I must be honest with you, Headman, they will not believe it. They will say that German spirit beats American materialism. They will point to our victories as proof. They will dismiss your analysis as defeatist." Speer was correct. When Hitler saw evidence of American production power, he became furious. He insisted that German quality would win, that American equipment was weak, and that American soldiers were cowards who would break under strong attack. He talked about German successes in Russia, North Africa, and the Atlantic. He demanded more production through willpower and discipline, not by changing how factories worked. Goering, the head of the Luftwaffe, ignored the report completely. He said his intelligence was better and that American production numbers were just propaganda. When shown photos of American factories, he said they were fake, movie sets made to scare Germany. Only inside Speer's ministry did Schneider's study have any effect. Speer started several programs trying to copy American mass production. He pushed for standardizing vehicles, making tanks simpler, and building bigger factories using assembly lines. But he faced constant resistance. The Wehrmacht wanted Tiger and Panther tanks, complex machines that took a long time to make. The Luftwaffe wanted advanced fighters with complicated engines. Every branch said quality could not be lowered. Speer did make some improvements. German war production grew in 1943 and 1944, but he could never make the big change that Schneider's study had shown was needed. Schneider himself was sent to the Eastern Front in May 1943, assigned to a Panzer Division's maintenance battalion. The transfer was officially said to be needed for manpower, but Schneider thought it was partly punishment for the report that embarrassed his bosses. He spent the next 2 years watching German forces slowly get worn down by the exact material advantage he had warned about. What Schneider had predicted in his report happened with almost perfect accuracy across every part of the war. The Jeep he examined in January 1943 was just the first ripple of a huge wave of American production that would eventually overwhelm the Axis powers. By the end of 1943, American factories had made 640,000 Jeeps. That number, which would help conquer 2 continents, was not an exaggeration. It was a careful, conservative count. By the end of the war in 1945, total Jeep production went over 640,000, and these vehicles were used on every front where American and Allied forces fought. The Jeeps became everywhere. Every American infantry division got 553 Jeeps as part of standard equipment. Armored divisions got over 600. Even non-combat units had plenty. The Jeep changed military movement in ways that fancy German vehicles could not, because it was simple, reliable, and endless in supply. In North Africa, American Jeeps supplied British long-range desert groups that attacked German supply lines. In Sicily and Italy, they drove on mountain roads that German vehicles could not. On D-Day, June 6, 1944, over 2,000 Jeeps landed on the Normandy beaches in the first wave. Within a month, 40,000 had arrived in France. The strategic effect was exactly what Schneider had predicted, but the Wehrmacht refused to see it. American forces could keep moving and fighting at a speed German forces could not match. When the U.S. Third Army under General George Patton moved across France in August 1944, it went so fast that German forces could not make strong defensive lines. Patton's army covered 400 miles in 1 month, supplied entirely by trucks, including thousands of jeeps carrying ammo, fuel, and communications gear. German forces struggled with movement. Their supplies still relied on horses. Even in 1944, over 80% of Wehrmacht transport was horse-drawn. Panzer divisions could move fast when they had fuel. But fuel was getting scarce. Supply columns moved slowly and were easy targets for air attacks. When equipment broke, repairs took days or weeks because replacement parts were not available. The Jeep's reliability advantage proved crucial in ways Schneider had noted, but couldn't fully predict. American maintenance records from Europe showed that Jeeps went over 10,000 miles between major mechanical failures. German Kubelwagen tanks lasted less than 4,000 miles. This meant American units spent less time fixing vehicles and more time on missions. Fewer vehicles were out of action waiting for repairs. The same number of vehicles could do more work. But the Jeep's effect went beyond logistics. It became a psychological weapon. German soldiers captured in France and Germany in 1944 and 1945 all said the same thing in interrogations. American forces seemed to have endless equipment. No matter how much was destroyed, more appeared. The constant stream of jeeps, trucks, and tanks made the Americans seem invincible, like an enemy that could never run out. This was not propaganda. This was real. American industrial production in 1944 reached almost unbelievable levels. 4,000 tanks per month, 2,000 artillery pieces per month, 11,000 planes per month, 300 ships per month. And behind all this, 640,000 Jeeps in 3 years, 98,000 Sherman tanks, 2 million trucks, 400,000 artillery pieces. Germany, fighting on many fronts, made about 40,000 armored vehicles of all kinds. During the whole war, America made that many Shermans in just 6 months. The difference Schneider had calculated by studying one simple Jeep in a warehouse at Kmersdorf turned out to be the strategic reality that decided the war. The philosophical gap between German and American approaches became more obvious as the war went on. Germany kept making more advanced weapons: the Tiger II tank, the Me-262 jet fighter, the Type 21 U-boat, each one technologically superior to Allied equivalents. But these weapons arrived in too few numbers and came too late to change the war's outcome. America kept improving existing designs rather than making totally new ones. The Jeep got small changes during the war, but it basically stayed the same. The Sherman tank was upgraded with stronger guns and better armor, but it used the same basic chassis. American strategy focused on sending enough equipment to the front in large amounts rather than waiting for perfect equipment in small numbers. By 1945, when Germany surrendered, the gap in resources was huge. Allied forces had full control of the air. Allied armored forces outnumbered German forces 10 to 1 in most areas. Allied supply lines could keep up attacks forever. Germany had been buried under exactly the flood of production that Schneider had warned about in his report 2 years before. Ernst Schneider survived the war. He was caught by Soviet forces in Poland in January 1945 and spent 4 years in a prison camp before he was sent back to West Germany in 1949. He never went back to military engineering. Instead, he worked for a civilian car company, focusing on commercial truck designs, until he retired in 1971. In his personal papers, saved after he died in 1986, there was a worn copy of his original Jeep analysis report. He had kept it through the war, through prison, and through the hard post-war years. In the margins were handwritten notes added over many decades showing how his predictions had come true. Next to his calculation of American Jeep production, he wrote final total 641,154. I underestimated. Next to his notes on American industrial power, he wrote, "We knew." We wrote it down. We refused to believe it. The Jeep that Schneider looked at in 1943 was eventually destroyed in an Allied bombing raid on Kmersdorf in 1944, but its impact lasted in unexpected ways. After the war, access to Schneider's report and other similar technical studies affected European car design. The idea of simplicity, reliability, and easy production that the Jeep showed started appearing in civilian vehicles. The British Land Rover, first made in 1948, was directly inspired by the wartime Jeeps that British soldiers had used and liked. Its designers chose simple design instead of complicated features. The vehicle used a ladder frame, leaf spring suspension, and a basic four-cylinder engine. It became one of Britain's most successful car exports. In Germany, the post-war Volkswagen. The Beetle's success owed a lot to lessons learned from American mass production methods. Ferdinand Porsche, who had designed the complicated Kubelwagen, used simpler ideas when designing the Beetle. The car was made for easy manufacturing with stamped steel body panels, very few parts differences, and assembly methods that needed only a little skilled labor. It became the best-selling car design in history. The bigger strategic lessons from Schneider's analysis were studied a lot in post-war military schools. The report became a case study showing how organizations can be blind to uncomfortable truths because of their own biases. German military leaders had good information about American industrial power. They had written it down, studied it, and then ignored it because it did not fit their basic beliefs about war. This kind of mistake was not only in Germany. Similar problems appear all through military history. Organizations that ignore evidence that goes against their rules, that dismiss threats that do not match expected patterns, that hold on to easy beliefs even when facts show otherwise. The Jeep itself became legendary. After the war, extra-military Jeeps went into civilian markets all over the world. They were used on European farms, African missions, and Asian villages. Their toughness and simple design made them perfect for developing areas. In many countries, Jeep became a common word for any small four-wheel drive car, like Xerox became for photocopiers. The civilian Jeep, made by Willys Overland in 1945, started a whole new type of vehicle. The idea of a simple, strong, go-anywhere car was so popular that it lasted long after military utility vehicles became complex